Now let's go through the design methodology of designing a gear mesh for speed reduction. So from this we'll get to know about how to do the calculation step by step and also how to go about the workflow, the CAD workflow in Fusion 360. So the input values are the driving pinion gear speed N1, that is the rotation, 1000 revolutions per minute, that's the input speed. The pinion pitch dia D1 is 100 mm. The pressure angle considered over here phi is equal to 20 degrees. The module selected is phi, and required speed reduction ratio or gear ratio is 0.5. That means we need to reduce the speed by half. So 0.5 is the speed reduction ratio. From that we can calculate the radius of the driven gear, the larger gear. So R1 by R2 is 0.5. 50 is the radius of the pinion, D1 by 2. So 50 divided by R2 is equal to 0.5. So R2 is equal to 100 and D2 is equal to 200. So 100 is the pinion and 200 is the driven gear, the pitch dia of both. Number of teeth on pinion N1 is equal to D1 by M, because M is equal to D by N. So just replacing M, cross multiplying. So N1 is equal to D1 by M. D1 is 100 divided by M is 5. So number of teeth on pinion N1, capital N1 is 20. Number of teeth on gear, that is the driven gear, N2 is D2 by M, that is equal to 200 by 5, that is 40. Driven gear output speed is 500 revolutions per minute. Now let's calculate the specifications regarding the tooth. So pinion base circle dia, the base circle dia corresponding to the pitch dia is pitch dia into cos phi. So 100 into cos 20 is the base circle dia for the pinion, that is 93.969. The addendum circle is pitch dia plus 2 into A, where A is 1 into M, that is the addendum A is 1 into M, which is equal to 5 mm. 1 into 5 is equal to 5 mm, and addendum B is 1.25 into M, which is 6.25. So addendum circle of pinion is pitch dia plus 2A, which is 110 mm, and addendum circle of pinion is pitch dia minus 2B, so that is 87.5. For the gear, for the driven gear, base circle dia is pitch dia into cos phi, that is 200 into cos 20, 187.9. And for the gear, addendum circle is 210 mm and addendum circle is 175.4. So with this data, now we can start designing in CAD. So the first step is to create the pinion pitch circle. So sketch on the plane, go to sketch, create the circle. We know the pitch circle dia is 100 mm from the data available. So give it a 100 value. So 100 is the dia of the circle. Now let's create another circle, which is a base circle, which is having the dimension of 93.969. So this is what calculated, 93.969. So this is the base circle based on which we will be creating the involute profile. So let's start by just creating this pitch circle as a construction element. So you can select this and go to an option over here where it says construction element and make this construction element. So the line will become hashed. So now let's start by creating the lines. So from the center, draw lines to the base circle edge. Draw around 5 lines. 1, 2, 3, 4, and 5. Now let's give them an angle. Before that we need to connect the two edges, the two endpoints for all the lines. So select this, connect the endpoints. Select this, this and this, this and this, and make all of these chords same length. So select all of the chords, control selecting all of them, go to equal and make them same length. Now we are going to specify angle over here. So let this angle be 10 degrees. Let this be 10 degrees. And we'll add one more segment just to make sure that the created profile is long enough. So one more segment over here. The chord, this chord has to be made equal in length to this one. So make it equal in length. So now we have 1, 2, 3, 4, 5 segments. Now we'll start creating the lines, the tangent lines. So select line command and select the lines, create the lines from the points. And then give tangency with respect to the base circle. So tangency should be with respect to the base circle. All of the lines, give them tangency with respect to the base circle. And the next step is to find out this length, which is 8.19 mm, and use that to specify the length of this line, 8.19. This one will be 2 into 8.19. This one will be 3 into 8.19. So similarly, we'll do it for all. And these are the lines which are created, 1, 2, 3, 4, 5 lines, increasing lengths in the multiples of 8.19. All are tangent to the base circle. So now the next is to connect them starting from here. We need to start from here. This is the first point, then second, third, fourth, fifth, and sixth. So using the spline command, we connected all of the points to create the involute profile. So this geometry is not fully constrained. As you can see, if I click and drag around, it will rotate. It is not fully constrained. So the next step would be that this profile, this spline which we created, we have to create another mirror spline on the other side so that we can create the tooth space. So the space between the two tooth, that is to be modeled, and that will be modeled and that will be cut from the solid of a addendum circle. So that's the workflow. So for that, we need to first create the addendum circles and addendum circles. So let's go to select the circle, and the size of the addendum circle for the pinion is 110. So create the addendum circle and create the dedendum circle. So this dedendum circle is 87.5. So for now, let's keep it as a construction element, both of them. Now the next step is to create a mirror line which is radial, which is originating from the center, to create a radial line which is the mirror line for mirroring this involute profile onto the other side to form the other face of the tooth. So since we will be modeling the space which is present in between the tooth, we need to mirror this involute profile on the other side and create that profile to cut it out from the addendum circle or addendum solid circle. So let's create another line over here which is originating from the center as shown over here. Just starting from the center and one line like this. Now we'll create another line which is connecting the pitch point to the center. So the pitch point is found out by finding the intersection point between the involute profile and the pitch circle of the pinion. So this is the pitch circle which is having the dia 100 mm. So finding the intersection point between the involute profile and the pitch circle will give us the pitch point, and from that pitch point, if we draw a line to the center, based on that we can calculate the tooth width and input the angle in the CAD and then mirror this profile based on that angle. So let's do that. So first create a line which is intersecting between the profile and the pitch circle. So this is that point. This is the intersection point. It has been snapped. It will automatically snap to the intersection point. Then go down to the center. So this line indicates that pitch line. Now let's fix this line. Let's right click on it and go to fix. We can fix any geometry to hold it in place so that it doesn't rotate with the dimensions. So fix this line and then give a value over here. So this value of angle has to be calculated. This value of angle will be calculation based on the circular pitch divided by the number of teeth and then divided by 2. So based on that, we will get an arc length. Based on that, we need to calculate the angle. So let's do that calculation next. So the angle subtended by one tooth can be calculated by calculating the circular pitch and then dividing circular pitch by 2. So pitch dia is 100 mm of the pinion, number of teeth on the pinion are 20. Circular pitch is pi d divided by n. So d over here is 100, n is 20, circular pitch is 15.708 calculated from this equation. So the tooth space width, that is circular pitch divided by 2. So circular pitch is basically the distance on the circumference from one point of the teeth to the corresponding point on the next teeth. But we want to find the arc length in the space between the tooth. So that will be 15.708 divided by 2, which is 7.854. Now we have the arc length. From that we have to calculate the angle. So the formula is arc length is equal to r into theta. So this is the arc length 7.854 and this is the radius 50, which is half of the diameter of pinion, and theta is the angle we need to find. So arc is equal to r into theta. R is 50, arc length is 7.854. 7.854 divided by 50 will give us the theta in radians, and then multiplying 180 divided by pi will give theta in degrees. On calculating, we'll get a theta of 9 degrees, which is the angle subtended by one tooth or one tooth space. So another easier way of doing this would be 360 divided by 20. 360 divided by 20 gives us 18 degrees. So 18 degrees is for the circular pitch. So the angle relating to the circular pitch is for 18 degrees. Then 18 divided by 2 is for one tooth width. So that's another way of doing it. Now going back to the CAD workspace. So this value of angle, which we had given earlier, it was 18.77. If we give it as 9 degrees, if we enter it as 9 degrees, so this will indicate where this point will be located once the next tooth starts. So the corresponding location of this point over here will be over here. So now based on this, we can make a line to mirror this profile on the other side. So for that, it's simple, just make another line originating from the center and give an angle of 4.5 from this. So give an angle of 4.5, make this line as construction element, also this line as construction element, also this line as construction element. So this line will be one which we'll be using for mirroring this profile. So go to create, go to mirror, select this, go to select the mirror line and select this. So as you can see, it is intersecting at this point. So this will be the mirror of the involute profile to form the gear teeth. The next one is to create the bottom land of the gear tooth space. So for that, first let us make all of these curves construction elements for ease of working. All of these as construction elements, whichever were used for creating the involute profile. So construction elements. Now we need to draw a line from this end point, from this point, the starting point of the involute, to the dedendum circle. So this is the base circle in black in the solid line, and in the hash line this is the dedendum circle. So from the base we need to draw a line till the dedendum circle. Next, again use the same line to mirror this with respect to this, get the mirror line, and now just convert this back into non-construction element, the dedendum circle. So convert this back into non-construction element, and also convert the addendum circle into non-construction element. So now this profile indicates the width between the two teeth, the space between the two teeth. So this and this will be used to cut from the solid cylinder of the addendum. Next, we create the solid cylinder for the addendum from which we can cut this profile out. So for that, let's come out of the sketch, go to extrude, select all of the profiles to form the solid cylinder for the addendum. So this will be the addendum cylinder. Extruded, let's have a width of 15 mm of the gear. Unhide the sketch again. So the sketch will automatically get hidden. We need to unhide it. And now use this profile and this profile to cut it, to cut the solid. Since you have already made the profile as per the dimensions, as per the parameters, now we just need to cut the profile from the solid cylinder of the addendum. So go to extrude, extrude cut, slide it and cut it and press OK. Now the next thing is go to pattern, go to circular pattern and select features and select this feature which we have cut over here. So the extrude which we cut, that feature has to be selected, and select the axis, which is nothing but the axis of the cylinder, and then enter the value, which is the number of teeth. So the quantity is 20 and press OK. So now the gear has been designed. Next we can add the root fillets to all of the teeth over here. So go to modify, go to fillet and select all of these edges at the bottom. So the fillets have been given with a 1.5 mm fillet all across.